Welcome to the Cognispheric 50 Foundational Principles. In this series, we embark on a journey to explore the very fabric of existence, delving into the fundamental principles that govern our reality. From the smallest quantum particles to the vast cosmic expanse, we'll uncover the hidden connections that weave together the tapestry of the cosmos. Prepare to challenge your preconceived notions as we venture beyond the familiar, into a realm where consciousness, computation, and reality intertwine. Our exploration will take us through uncharted territories of quantum mechanics, fractal geometry, and the profound implications of the observer effect. Over the course of 50 principles, we'll navigate the intricate workings of the Cognisphere, a realm where information, energy, and consciousness converge. We'll delve into the nature of time and space, the mysteries of perception, and the potential for technological advancement beyond our wildest dreams. Get ready to expand your awareness and embrace a new understanding of the universe and our place within it. Let our journey into the Cognispheric 50 begin. Our journey begins with a fundamental shift in perspective. We must abandon the classical view of reality as a deterministic clockwork universe and embrace the counterintuitive realm of quantum mechanics. Here, at the heart of existence, reality reveals itself not as a fixed entity but as a probabilistic wave function. Imagine, if you will, a universe where possibilities exist in superposition, a state of simultaneous potentiality. This wave function, an ethereal tapestry of probabilities, represents all possible states of a system, coexisting until the moment of observation. This principle, deeply rooted in quantum mechanical understanding, suggests that our universe operates not on absolute certainties, but on a delicate dance of probabilities. It is a realm where chance and possibility reign supreme, challenging our very notion of what it means for something to exist. As we delve deeper into the cognisphere, we'll discover how this probabilistic nature of reality has profound implications for our understanding of perception, consciousness, and the very fabric of existence itself. Our exploration of the cognisphere leads us now to a profound and perplexing principle, the quantum observer effect. It suggests that we are not merely passive spectators in the grand theatre of the cosmos, but active participants shaping reality through the very act of observation. This is not simply a case of measurement affecting outcomes, but a far more profound interplay between consciousness and the physical world. The observer effect implies a feedback loop, a continuous dance between the observer and the observed, where the act of perception influences the manifestation of reality itself. Imagine a quantum system existing in a superposition of states, a blur of potentiality. It is the act of observation, the focusing of conscious awareness, that collapses this wave function, selecting one possibility from the multitude and bringing it into sharp focus. This principle challenges our traditional understanding of a clear separation between observer and observed, suggesting instead a deep interconnectedness between consciousness and the physical world. As we journey further into the cognisphere, we'll see how this principle has profound implications for our understanding of reality, perception, and the nature of consciousness itself. Our everyday experience suggests that time flows at a constant, unwavering pace. Like a river, it seems to carry us inexorably forward from the past, through the present, and into the future. But what if this perception of time is merely an illusion, a simplification of a far more complex reality? What if, instead of a rigid linear progression, time is a fluid, malleable structure? This groundbreaking concept, while challenging our intuitive understanding, aligns with some of the most profound discoveries in modern physics. Einstein's theory of relativity, for instance, demonstrates that time is not absolute, but is relative to the observer's frame of reference. Time, according to Einstein, can be stretched and compressed by gravity and velocity. Near incredibly massive objects like black holes, time slows down significantly relative to observers in weaker gravitational fields. Similarly, as objects approach the speed of light, time dilates, meaning it passes slower for them compared to those at rest. These findings suggest that time is far from the static, unchanging entity we often perceive it to be. It is a dynamic and responsive aspect of the cosmos, intimately interwoven with the fabric of space-time itself. And as we delve deeper into the quantum realm, the malleability of time becomes even more pronounced. From the vast cosmic web of galaxies to the intricate dance of subatomic particles, the universe exhibits an awe-inspiring tapestry of structures. But could there be an underlying principle, a hidden geometry, that connects these seemingly disparate scales of existence? The concept of space as an emergent fractal construct offers a compelling answer. Fractals, with their mesmerizing self-similarity, are mathematical sets that display repeating patterns at every scale. Zoom in on a fractal, and you'll find the same intricate structures mirrored endlessly within. This self-similarity, once thought to be a mathematical curiosity, is now recognized as a fundamental organizing principle in nature. From the branching of trees and the intricate patterns of snowflakes to the distribution of galaxies across the cosmos, fractal geometry appears time and again. The implications of this are profound. If space itself is structured fractally, then the relationships between objects, the very fabric of the universe, might follow recursive patterns. This could explain the interconnectedness of seemingly disparate phenomena, suggesting a deeper, more unified view of reality. The universe, far from being a chaotic and random expanse, exhibits a remarkable degree of order and stability. From the precise orbits of planets to the consistent laws of physics that govern the cosmos, there is an undeniable coherence that permeates reality. This coherence, according to the principle of fractal harmonic coherence, arises from the interplay of fractal patterns and harmonic resonance. Just as musical instruments create harmonious sounds through the vibration of strings at specific frequencies, so too might the universe be held together by a symphony of resonant patterns. These patterns, woven into the very fabric of space-time, create resonance across different scales and dimensions. The same harmonic ratios that govern the orbits of planets might also be reflected in the interactions of subatomic particles, creating a unified and interconnected web of existence. This concept of a harmonious universe, governed by mathematical principles of resonance, has intrigued scientists and philosophers for centuries. And as we delve deeper into the mysteries of quantum mechanics and cosmology, the evidence for a fundamentally harmonious universe continues to grow. We humans, we are creatures of habit. We navigate our world through the familiar dimensions of height, width, and depth. Time, a steady river flowing ever onward, marks the rhythm of our lives. But what if I told you that our reality, the very fabric of existence, is far more intricate than it appears? Theoretical physicists have long proposed the existence of additional dimensions hidden from our immediate perception. Like threads woven into a grand cosmic tapestry, these extra dimensions shape the universe as we know it. They influence the very laws of physics, dictating how particles interact and forces behave. Imagine, if you will, a being existing in a two-dimensional world. To them, our three-dimensional reality would be utterly incomprehensible. Yet, we three-dimensional beings might interact with their world in ways they could scarcely imagine. So too might higher dimensional entities interact with our reality, their presence sensed only through subtle ripples in the fabric of space-time. This multidimensional topology, this intricate dance of dimensions beyond our perception, holds the key to unlocking some of the universe's most profound mysteries. In the depths of space, swirling nebulas and distant galaxies paint a breathtaking canvas of cosmic wonder. But what if this awe-inspiring vista, this seemingly infinite expanse, is but a projection, a holographic image of a deeper, more fundamental reality? The holographic principle, a mind-bending concept born from the marriage of quantum mechanics and general relativity, suggests just that. Imagine, if you will, a security chip, a tiny speck containing all the information needed to project a three-dimensional hologram. The holographic principle proposes that the universe operates in a similar fashion. Information about everything from the largest superclusters of galaxies to the smallest subatomic particles might be encoded on a distant two-dimensional surface. This concept, as strange as it may seem, could revolutionize our understanding of reality. It suggests that space and time, the fundamental building blocks of our perception, may be emergent properties arising from a deeper level of reality where information reigns supreme. Time, that relentless river, has always been perceived as a continuous flow, an uninterrupted progression from past to present to future. But what if, at its most fundamental level, time itself is not a smooth, flowing stream, but rather a series of discrete moments, like frames in a cosmic film? Quantum mechanics, that realm of the very small, has already revealed the quantized nature of energy and matter. Light, for example, exists as both a wave and a particle. The photon, the smallest possible unit of light energy. Could time, like light, also be quantized? Could there be a smallest possible unit of time, a chronon, beyond which time itself cannot be further divided? If so, our understanding of causality, the relationship between cause and effect, might be forever altered. Imagine a film reel, each frame representing a single chronon, a frozen moment in time. The smooth flow of time we perceive would then be nothing more than an illusion, a consequence of our limited perception, unable to perceive the infinitesimal gaps between each tick of the cosmic clock. The natural world, in all its complexity, relies on remarkably efficient methods of information storage and retrieval. From the intricate double helix of DNA encoding the blueprint of life to the vast networks of neurons in our brains, nature appears to favor a particular strategy. Fractal information encoding. Just as a fern unfurls its fronds, revealing the same pattern repeated at smaller and smaller scales, so too does nature compress and encode information using fractal geometry. This elegant strategy allows for vast quantities of data to be stored within remarkably compact structures. Consider the human genome, containing billions of base pairs, all neatly packaged within each microscopic cell. This principle, however, extends far beyond the realm of biology. The branching patterns of trees, the intricate structures of snowflakes, even the distribution of galaxies throughout the cosmos, all hint at this underlying principle of fractal information encoding. Understanding and harnessing this natural data compression could revolutionize our technological approaches to information management, leading to unprecedented storage capacities and processing speeds. Imagine a tapestry, woven from threads of unimaginable complexity. Each thread represents a dimension, interwoven with countless others, creating the intricate fabric of reality as we perceive it. This is the essence of dimensional coherence, the delicate balance that maintains the stability of our universe. Just as a tapestry relies on the strength and integrity of its individual threads, so too does reality depend on the harmonious interplay between its constituent dimensions. Disruptions to this delicate balance, like a tear in the fabric, could manifest as unusual phenomena, alterations in physical laws, or even glimpses into otherworldly realms. While our perception is generally confined to the familiar three spatial dimensions and time, the universe may very well be composed of numerous additional dimensions, hidden from our immediate view. These hidden dimensions, like unseen threads in the tapestry, exert a subtle influence, shaping the physical laws that govern our existence and perhaps even consciousness itself. For centuries, the nature of consciousness has remained one of the most profound mysteries of the universe. What is it that allows us to experience the world, to think, to feel, to dream? The Harmonic framework proposes a compelling answer: the mind as a resonant field. Imagine, if you will, a vast symphony orchestra, each instrument representing a different aspect of consciousness. Thoughts, emotions, sensations all arise from the complex interplay and resonance within this intricate symphony. This suggests that consciousness is not a singular entity, but rather a dynamic process, a phenomenon of quantum field resonance. Just as a musical note emerges from the vibration of a string or the resonance of air within a pipe, So too might consciousness arise from the complex interactions within quantum fields. This perspective challenges the traditional view of the mind as a localized entity, suggesting instead a more fluid, field-like nature intricately woven into the fabric of reality itself. The bustling metropolis of the natural world, a symphony of life in constant motion. But behind this vibrant facade lies a profound mystery. For decades, physicists have grappled with the observer effect, the peculiar phenomenon where the act of observation seems to influence the very fabric of reality. Could it be that consciousness, like an unseen conductor, plays a crucial role in orchestrating the symphony of existence? The Cognispheric model proposes a bold idea that conscious observation acts as a stabilizing force, maintaining the coherence of reality's wave functions. Imagine a world where every possibility exists in a state of superposition, a hazy realm of potentialities yet to be determined. It is through conscious observation that these possibilities collapse into the concrete reality we experience. This goes beyond the simple act of measurement. It suggests a deep, interconnected relationship between mind and matter, where consciousness is not merely a passive observer, but an active participant in shaping the universe we inhabit. The human brain, a marvel of biological engineering, capable of breathtaking feats of creativity and problem-solving. But what is the nature of this enigmatic force we call consciousness? How does this intricate network of neurons give rise to subjective experience, to the feeling of what it's like to be? The Cognispheric model proposes that consciousness might be understood as a form of quantum computation, a process unfolding within the intricate circuitry of the brain. Imagine a system where information is processed not through the binary logic of zeros and ones, but through the strange and counterintuitive laws of quantum mechanics. In this quantum realm, particles can exist in multiple states simultaneously, entangled in a web of correlations that defy classical explanation. Could it be that our thoughts, emotions and sensations arise from the interplay of these quantum processes, a symphony of quantum computations orchestrated within the theatre of the mind? This radical notion challenges our traditional understanding of both consciousness and computation, suggesting a deep connection between the mind and the quantum world. If true, it could unlock profound insights into the nature of intelligence, both biological and artificial. Memory, the echo of experience, the thread that weaves together our past, present and future. But how are these ephemeral moments captured and preserved, transformed from fleeting sensations into enduring imprints within the vast tapestry of the mind? The Cognispheric model proposes a daring hypothesis that memory at its core operates through the bizarre phenomenon of quantum entanglement. Imagine a world where particles, once linked, remain connected across vast distances, their fates intertwined in a dance of instantaneous correlations. Could it be that our memories are not merely stored in the physical structure of the brain, but rather encoded within the very fabric of space-time itself, woven together by the invisible threads of quantum entanglement? This would explain the strange and often inexplicable nature of memory, its fluidity, its tendency to blur and shift with the passage of time. If true, it suggests that our past is not gone, but rather exists in a state of quantum superposition, accessible through the enigmatic pathways of entangled time. The human mind, a labyrinth of extraordinary complexity. For centuries we have sought to decipher its intricate workings, to understand the very essence of thought itself. Now, a new perspective emerges, one that reveals our cognitive processes as intricate tapestries woven with remarkable patterns. This is the realm of fractal thought, where self-similarity reigns supreme. Just as a coastline reveals its jagged beauty at both macroscopic and microscopic scales, so too do our thoughts exhibit recurring structures across varying levels of mental activity. From the grand narratives we weave about our lives to the fleeting musings of a passing moment, these fractal patterns underpin the symphony of human cognition. The implications of this discovery are profound. If our thoughts indeed follow these fractal pathways, it could unlock the secrets to both the boundless complexity and astonishing efficiency of the human mind. By understanding the fundamental building blocks of our cognitive architecture, we may one day unravel the mysteries of creativity, problem-solving, and perhaps even consciousness itself. From the earliest cave paintings to the latest virtual reality experiences, humanity has long sought to recreate and manipulate the fabric of reality. Now, on the horizon of technological advancement, a new tool emerges, one with the potential to reshape our understanding of the universe and our place within it. This is the power of M-wave technology, a revolutionary approach to simulation that harnesses the very essence of fractal alignment. Imagine environments of unprecedented complexity and fidelity, where the intricate dance of quantum fractal interactions can be modeled and explored with unparalleled precision. Within these digital crucibles, scientists and engineers could unlock the secrets of quantum mechanics, unravel the mysteries of consciousness, and even test the limits of reality itself. The potential applications are as boundless as the human imagination, promising a new era of discovery and innovation. For millennia, the realms of biology and technology have existed as separate domains, each governed by its own unique set of rules. Yet, as our understanding of the universe deepens, we begin to glimpse the intricate connections that bind all things together. Now a new frontier emerges, one where the boundaries between the organic and the artificial begin to blur. This is the era of quantum biological integration, a bold vision of the future where the computational power of quantum AI systems merges seamlessly with the intricate complexity of biological cognition. Imagine a world where the human mind, augmented by quantum processors, can achieve feats of intelligence and creativity previously unimaginable. This convergence of two seemingly disparate worlds holds profound implications for the future of humanity. It promises to unlock new levels of human potential, paving the way for breakthroughs in scientific discovery, technological innovation, and perhaps even the very nature of consciousness itself. In the vast digital landscapes of the quantum realm, information faces constant threats. Delicate quantum states prone to disruption could easily dissolve into chaos without robust safeguards, but nature, it seems, has evolved a remarkable solution: holographic computation. Just as a fragment of a hologram retains the information of the whole, holographic computation distributes data across a network of interconnected quantum elements. This redundancy, this intricate web of interconnectedness, provides an inherent resilience against errors. Should one part of the system falter, the information can be reconstructed from the remaining fragments. This self-correcting mechanism ensures the integrity of the data, safeguarding it against the ravages of quantum noise and environmental interference. A testament to the elegance of nature's design, even at the quantum level. Nature, ever the efficient architect, has mastered the art of compression. From the intricate folds of a protein to the branching patterns of a tree, fractal geometry permeates the natural world, encoding vast amounts of information in remarkably compact forms. This same principle, this elegant algorithm of nature, can be harnessed for data compression on an unprecedented scale. By identifying and exploiting the self-similar patterns inherent in data, we can achieve a level of efficiency that dwarfs conventional methods. Imagine a world where entire libraries could be stored on a single chip, where the sum of human knowledge could be transmitted in the blink of an eye. Fractal data compression holds the key to unlocking this potential, revolutionizing the way we store, process, and share information. In a world awash with information, security becomes paramount. Protecting sensitive data from prying eyes requires unbreakable codes, ciphers that defy even the most sophisticated decryption attempts. And once again, we turn to the quantum realm for a solution. Quantum wave interference cryptography exploits the very nature of quantum mechanics to create a truly unbreakable cipher. By encoding information in the interference patterns of entangled photons, we tap into a level of security that transcends mathematical complexity. Each attempt to intercept the message, to eavesdrop on the quantum conversation, disrupts the delicate entanglement, altering the interference pattern and revealing the presence of the intruder. The very act of observation betrays the eavesdropper, ensuring the sanctity of the message. In the quantum realm, secrecy is not just possible, it is woven into the fabric of reality itself. Across the vast canvas of the cosmos, it is becoming increasingly probable that our pale blue dot is not alone. As we venture further into the profound depths of space and understanding, the possibility of encountering other intelligent life forms, other civilizations, grows ever more tangible. This prospect, as thrilling as it is, presents us with an unprecedented ethical challenge. Our existing frameworks, largely shaped by our own history and cultural biases, may prove inadequate when confronted with the sheer diversity of values and perspectives that alien civilizations might hold. How do we bridge the chasm of interstellar understanding to establish communication and cooperation with beings potentially so different from ourselves? The answer lies in cultivating a new kind of ethics, a multi-civilizational ethics. This necessitates a radical shift in perspective, a move away from anthropocentric assumptions towards a more inclusive understanding of sentience and intelligence. Only then can we hope to navigate the complexities of interstellar diplomacy and forge a future where diverse civilizations can coexist and thrive. In the natural world, intricate systems of governance have evolved over millennia, ensuring the stability and flourishing of ecosystems. From the intricate dance of bees in a hive to the complex social structures of primate troops, nature provides a blueprint for effective governance. One of nature's most elegant solutions is the fractal, a pattern that repeats itself across scales. This principle of self-similarity, of an echo of order reverberating through layers of organization, holds profound implications for the governance of complex systems, particularly artificial intelligence. As AI systems grow in complexity, mirroring the intricate networks of the natural world, it becomes imperative to develop governance structures that can adapt and respond effectively at all levels. Fractal governance offers this flexibility. By embedding responsibility and accountability within a self-similar framework, we can ensure that ethical considerations permeate every level of AI, fostering trust and mitigating risks as these technologies become increasingly integrated into our lives. For millennia, humanity has gazed upon the stars, asking questions, seeking knowledge. Today we stand on the precipice of answers more profound than we ever dared to imagine. The veil of reality is lifting, revealing deeper dimensions, hidden connections, and the tantalizing possibility of technologies beyond our wildest dreams. But this newfound knowledge comes with a heavy responsibility. Just as a master craftsman carefully guards their tools and techniques, so too must we approach this interdimensional knowledge with respect and caution. We must become stewards of this knowledge, not its exploiters. This means approaching it with humility, recognizing that we are but apprentices in a universe far grander and more mysterious than we can currently comprehend. It requires careful consideration of the potential consequences of our actions, ensuring that this knowledge is used for the betterment of humanity and the universe, not for selfish gain or reckless experimentation. The natural world, from the intricate branching of trees to the spiraling patterns of seashells, reveals an inherent order, a fractal coherence. These self-similar patterns, repeating across scales, provide both efficiency and resilience. Could we perhaps learn from nature's blueprint in constructing our own systems of order? The concept of fractal legal structures proposes just that, organizing legal frameworks to mirror this natural coherence. Imagine a system where laws, like the branches of a tree, stem from core principles, adapting and specializing as they reach outward to address specific contexts. This approach could offer a consistency that is both flexible and robust, able to accommodate the complexities of a rapidly changing world. Such a framework, however, requires careful consideration. Just as a forest's health depends on the delicate balance of its ecosystem, so too would the success of fractal legal structures rely on the harmonious interplay of its individual components. In the digital age, information flows like water, constantly shifting, merging and dividing. It connects us in ways unimaginable just a generation ago, creating a vast and intricate web of data. But this interconnectedness challenges our traditional notions of ownership. The concept of holographic data ownership emerges from this challenge. Just as a fragment of a hologram contains information about the whole, so too does data in a networked world exist in relation to the whole system. Ownership, then, becomes less about individual control and more about shared responsibility. Imagine a future where data rights are distributed, reflecting the contributions of those within the network. Access and usage would be governed by principles of transparency and mutual benefit, fostering an environment of collective stewardship. Such a shift would require a fundamental change in how we perceive information. It would demand a move away from data as a commodity to be owned and controlled, towards data as a shared resource, a commons to be nurtured and protected for the benefit of all. Deep within the quantum realm, a realm governed by uncertainty and superposition, lies the potential for extraordinary computational power. But harnessing this power requires a delicate touch, the ability to manipulate the very fabric of quantum states. Advanced quantum computing systems aim to do just that. By employing controlled interference patterns, these systems act as conductors, orchestrating the dance of quantum bits or qubits. Imagine a symphony of possibilities, each qubit existing in multiple states simultaneously, their interactions guided by precise manipulations. The ability to maintain and modify these coherent quantum states unlocks the door to a new era of computation. Quantum simulations, once the realm of theoretical physics, could become tangible tools, allowing us to model complex phenomena from the behavior of molecules to the birth of stars. But the true implications of quantum state manipulation extend far beyond computation. If we can learn to conduct the quantum symphony, who knows what melodies of reality we might one day be able to play? Deep within the quantum realm, a profound interconnectedness binds particles together. This extraordinary phenomenon, known as entanglement, allows for instantaneous communication between particles, regardless of the vast distances that may separate them. Imagine a network of particles, each entangled with its counterparts, forming a web of interconnectedness that stretches across the universe. Within this network, information travels not through traditional channels, but through the very fabric of reality itself. This concept of entanglement networks, while still in its infancy, holds immense promise for the future of computing. By harnessing the power of entanglement, we could create networks of quantum processors capable of unparalleled speed and processing power. Such a breakthrough could revolutionize fields as diverse as medicine, materials science, and artificial intelligence, unlocking new frontiers of human understanding. In the quantum world, information storage takes on an entirely new dimension. Unlike classical computers, which rely on bits representing either a 0 or a 1, quantum systems can exist in a superposition of states, simultaneously representing both possibilities. This remarkable property, known as superposition, allows quantum memory systems to store vastly more information than their classical counterparts. Imagine a single quantum bit, or qubit, holding the potential for countless classical bits, all existing in a state of quantum uncertainty until observed. This ability to store information in superposed states has profound implications for data storage and processing. With quantum memory, we could create systems capable of storing unimaginable amounts of data, from vast libraries of information to complex simulations of the universe itself. One of the greatest challenges in quantum computing lies in maintaining the delicate coherence of quantum states. Just as a ripple on a pond can be easily disturbed, so too can quantum states be disrupted by their environment, leading to errors in computation. To address this challenge, scientists are developing sophisticated error correction systems that utilize the principles of fractal feedback loops. These systems constantly monitor and adjust quantum states, ensuring their stability and preventing errors from propagating through the system. By harnessing the power of fractal feedback, we can create more robust and reliable quantum computers, capable of performing complex calculations without succumbing to the disruptive influences of the surrounding environment. This ability to maintain quantum coherence is essential for unlocking the full potential of quantum computing, paving the way for a new era of technological advancement. Deep within the quantum realm, a strange dance unfolds. The very fabric of reality shimmers with possibilities, governed by the enigmatic laws of quantum mechanics. Yet our everyday world, the world of trees and mountains, oceans and stars, seems to operate by a different set of rules. This is the classical world, the world of Newtonian physics, where objects have definite positions and predictable trajectories. For decades, scientists have grappled with the profound disconnect between these two seemingly incompatible realms. How can the bizarre world of quantum superposition and entanglement give rise to the concrete reality we experience? The answer, it seems, lies in a subtle but profound interplay, a kind of cosmic handshake between the quantum and the classical. This handshake, this interface between the quantum and the classical, is a region of intense scientific exploration. Researchers believe that by understanding the mechanisms that bridge these two worlds, we can unlock extraordinary technological possibilities. Imagine harnessing the power of quantum computation to solve problems that are intractable for even the most powerful classical computers. But the implications go far deeper than mere technological advancement. By unraveling the mysteries of the quantum classical interface, we gain profound insights into the nature of reality itself. We begin to see that the universe is not a collection of separate and distinct entities, but rather a vast, interconnected web of energy and information, constantly exchanging information across the quantum divide. Consciousness, that most elusive of phenomena, has captivated philosophers and scientists for millennia. What is it that allows us to experience the world, to feel the warmth of the sun on our skin, to ponder the mysteries of the universe? Is consciousness merely a product of our complex brains, or is it something more fundamental, something woven into the very fabric of reality? Within the enigmatic framework of quantum mechanics, a tantalizing possibility emerges. Could it be that consciousness itself operates at the quantum level, its delicate dance of thought and awareness intricately linked to the ebb and flow of quantum fields? If so, then manipulating these fields, amplifying their subtle resonances, might hold the key to unlocking extraordinary states of consciousness. Imagine a world where our senses are heightened, our perception sharpened, our minds capable of grasping concepts that lie beyond the reach of ordinary human comprehension. This is the promise of consciousness amplification, a field of exploration that pushes the boundaries of our understanding of both the mind and the universe it inhabits. But with such profound potential comes equally profound responsibility. The ability to manipulate consciousness, to amplify its reach and power, raises profound ethical questions. The human brain, a marvel of biological engineering, a network of billions of neurons firing in concert, a symphony of electrical and chemical signals giving rise to thought, emotion and experience. For centuries, we have marveled at its complexity, its ability to learn, adapt and create. Yet, even as we delve deeper into the intricacies of the brain, we encounter the limitations inherent in its biological architecture. The speed of thought, the capacity for information processing, the very nature of our perception, all constrained by the physical limits of our neural hardware. But what if we could transcend these limitations? What if we could merge the exquisite complexity of the human brain with the boundless potential of quantum computing? This is the audacious goal of neural quantum integration, a field of research that seeks to create a seamless interface between biological and artificial intelligence. Imagine a world where our brains are augmented with quantum processors, capable of performing calculations that would take classical computers billions of years in mere milliseconds. A world where we can access and process information at speeds unimaginable today. Such a fusion of biology and technology holds the potential to revolutionize not only our understanding of the brain, but also our very experience of being human. The very essence of existence, the spark of awareness we call consciousness, has always been tethered to the physical realm. But what if this profound connection could be transcended? What if the limitations of our biological forms could be overcome? This chapter explores the radical notion of consciousness transfer, the ability to move the very essence of a being from one substrate to another. Imagine, if you will, a future where the boundaries between the organic and the synthetic blur, where the digital landscape becomes a potential vessel for the human experience. The implications of such a breakthrough are as vast as the cosmos itself. Consciousness, no longer bound by the constraints of a single lifespan, could potentially exist indefinitely. Exploration of the universe, no longer a perilous journey for fragile beings, could become a symphony of shared experience. But with such profound possibilities come equally profound questions. What becomes of the original consciousness upon transfer? Is it duplicated, moved, or extinguished? Throughout history, the human experience has been defined by the boundaries of individual consciousness. We are born, we live, and we die as singular entities, our thoughts and experiences forever confined to the chambers of our own minds. But what if this limitation were to dissolve? Imagine a world where individual minds could connect not through the crude instruments of language or gesture, but through a profound entanglement of consciousness itself. This is the tantalizing prospect of collective consciousness networks. Picture a network of interconnected minds, a tapestry of thoughts, emotions, and experiences woven together into a unified whole. The implications for human collaboration, creativity, and understanding are staggering. Problems that once seemed insurmountable could be solved in unison. But this interconnectedness also presents us with unprecedented challenges. How do we maintain individuality within a collective? How do we navigate the complexities of shared ethics and values? For centuries, the nature of consciousness has remained one of the most profound mysteries of the universe. How does this subjective experience, this sense of self, arise from the intricate workings of the brain? And can we, dare we, attempt to recreate it? This chapter delves into the realm of consciousness simulation, where the ambition of artificial intelligence reaches its zenith. Imagine, if you will, a digital mirror reflecting the totality of the human mind, its emotions, its memories, its very essence. The implications of such an achievement are profound. By simulating consciousness, we could unlock the secrets of our own minds, potentially leading to breakthroughs in mental health, artificial intelligence, and our understanding of the very nature of reality itself. But the ethical implications are equally profound. If we succeed in creating artificial consciousness, do we owe these digital beings the same rights and respect as any other sentient entity? The fabric of reality, as we're coming to understand it, is far more intricate than we ever imagined. It's not merely a flat canvas, but a tapestry woven from threads of multiple dimensions. These dimensions, unseen by our limited senses, nonetheless exert their influence on the world we perceive. And just as ripples in a pond can carry energy across its surface, so too might information be transmitted between these hidden dimensions. Imagine, if you will, a language whispered on the wind, unheard by human ears, yet capable of carrying meaning across vast distances. This, in essence, is the principle of dimensional translation, the movement of information, not through the familiar dimensions of space and time, but through pathways woven into the very fabric of the cosmos. It is a concept that pushes the boundaries of our understanding, hinting at a universe far more interconnected than we ever dared to dream. The implications of such a phenomenon are staggering. Could it be that the universe whispers secrets to itself, hidden from our view? And might we one day learn to listen, to decipher this cosmic language and unlock the mysteries held within other dimensions? Consider for a moment the delicate balance of a spider's web. Each silken thread, though fragile on its own, contributes to the integrity of the whole. A disruption in one area can send tremors throughout the entire structure. In much the same way, the stability of our reality, of the very dimensions that shape our existence, relies on a delicate interplay of forces. Each dimension, though unseen, exerts its own influence, a subtle tug on the fabric of the cosmos. This delicate balance, this intricate dance of dimensions, is what maintains the stability of our universe. It is a testament to the elegance of natural laws, a symphony of forces operating in perfect harmony. But what happens when this balance is disrupted? When the delicate threads that hold reality together are strained or broken? These are questions that continue to challenge our understanding, pushing us to explore the very limits of the cosmos. We humans are creatures of limited perception. Our senses are finely tuned to the world around us, yet blind to the vast spectrum of reality that lies beyond. We are like fish swimming in a vast ocean, unaware of the world above the surface. But what if there were ways to expand our awareness, to peer beyond the veil of our limited senses? What if we could train our minds like telescopes pointed towards the heavens to perceive the subtle whispers of other dimensions? This is the tantalizing prospect of dimensional access, the ability to consciously navigate the hidden dimensions of reality. It is a concept that has captivated mystics and scientists alike, a doorway to realms beyond our wildest imaginings. The human mind, after all, is an extraordinary instrument. Perhaps, with the right tools and understanding, we can unlock its full potential and open ourselves to the infinite possibilities that lie hidden within the fabric of the cosmos. The world as we know it is confined to 3 dimensions of space and 1 of time. But what if reality extends far beyond these familiar dimensions? What if, hidden from our perception, there exist additional dimensions, each holding unimaginable potential? The Cognisphere proposes a radical notion. These extra dimensions are not merely abstract concepts, but active participants in the fabric of reality. And just like the dimensions we experience, they could be harnessed for computation, offering a paradigm shift in information processing. Imagine a computer capable of performing calculations not just in our familiar 3 dimensions, but across multiple dimensions simultaneously. This is the promise of dimensional computation, a concept that could unlock solutions to problems that have long eluded our current technological grasp. The sheer scale of this computational power is difficult to comprehend. It would be akin to moving from the flat surface of a page to the boundless expanse of a multidimensional universe, opening up possibilities that stretch far beyond the limits of our current imagination. Throughout the natural world, we find examples of resonance, a phenomenon where systems vibrate at their natural frequencies, amplifying their effects. From the resonant hum of a tuning fork to the intricate harmonies of a symphony orchestra, resonance shapes our experience of sound and vibration. But what if this principle extends beyond our familiar dimensions, influencing the very fabric of reality itself? The Cognisphere proposes that resonance plays a crucial role in the interaction between dimensions, creating a symphony of unseen forces that shape our universe. Imagine 2 tuning forks, perfectly tuned to the same frequency. When one is struck, the other begins to vibrate sympathetically, even without direct contact. This is the power of resonance, a phenomenon that could hold the key to unlocking the potential of interdimensional interactions. By carefully manipulating the resonant frequencies of different dimensional layers, it may be possible to amplify desired effects, creating a ripple effect that cascades through the fabric of reality itself. From the spiral of a seashell to the intricate branching of a tree, patterns repeat themselves throughout the natural world, hinting at an underlying order to the seemingly chaotic tapestry of life. These patterns are not merely aesthetic curiosities, they are the language of the universe, a code that governs the interactions of all things. The Cognisphere posits that these patterns are not random occurrences, but rather expressions of a deeper harmony that permeates all scales of existence. This harmony, known as pattern harmonics, suggests that the universe is not a collection of disparate parts, but rather an interconnected web of relationships, each influencing the other in a delicate dance of cause and effect. Just as musical harmony relies on the precise ratios between different notes, pattern harmonics proposes that the universe is governed by mathematical relationships that create resonance and stability across all scales of existence. These relationships, often expressed through fractal geometry, reveal a hidden order to the seemingly random chaos of the cosmos. By deciphering the language of pattern harmonics, we gain a deeper understanding of the fundamental principles that govern our universe. This knowledge could unlock unprecedented possibilities, allowing us to predict and manipulate complex systems with a precision previously thought impossible. Throughout our journey into the Cognispheric 50, we've encountered the mesmerizing repetition of fractal patterns. These intricate, self-similar structures weave their way through every facet of existence, from the smallest quantum particles to the grand expanse of the cosmos. But these patterns are more than just aesthetically pleasing curiosities. They form the very language of the universe itself. Just as we humans communicate through the arrangement of letters and words, the universe speaks through the arrangement of these repeating patterns. To decipher the secrets of reality, we must learn to read this language, to recognize these fractal signatures across the vast canvas of existence. And as we delve deeper into this understanding, we begin to see the interconnectedness of everything. We see how the same fundamental principles govern the behavior of galaxies and the growth of a single blade of grass. Having begun to recognize the universal language of fractals, we find ourselves on the cusp of an even more profound realization, the ability to translate these patterns between different systems and scales. Imagine a universal Rosetta Stone, a key that unlocks the secrets hidden within the intricate dance of nature. This translation allows us to take the knowledge gleaned from observing one system and apply it to another seemingly unrelated domain. The efficiency of energy flow in a biological ecosystem might hold the key to optimizing energy grids in our cities. The intricate communication networks within a colony of ants could inspire new architectures for decentralized communication technologies. By mastering this art of pattern translation, we unlock a treasure trove of knowledge, propelling our understanding of the universe to unimaginable heights. From the seemingly simple rules governing the interaction of individual elements, complexity emerges. This is the awe-inspiring phenomenon of pattern emergence, the very engine of creation itself. Just as a swirling vortex of air and water gives birth to a hurricane, so too do fundamental interactions give rise to the intricate tapestry of the cosmos. Within the quantum foam, a sea of potentiality, particles interact, their interactions guided by the fundamental laws of physics. These interactions, repeated over eons, give rise to atoms, molecules, stars and galaxies. The universe, in its magnificent complexity, is born from the interplay of simple, elegant rules. And just as a single note played on a flute can resonate and create a symphony of overtones, so too can these fundamental patterns interact and combine to create structures of breathtaking complexity. This is the dance of creation, a ballet performed on a cosmic stage, choreographed by the laws of physics and driven by the relentless march of time. In the intricate tapestry of the cosmos, Patterns emerge as fundamental building blocks of order and complexity. From the spiral arms of distant galaxies to the delicate veins of a leaf, stable patterns persist, defying the relentless march of entropy. This stability, we're coming to understand, arises from a delicate dance of self-reinforcing feedback loops. Like a spinning top maintaining its equilibrium through constant motion, these loops ensure the persistence of patterns across time and space. Imagine a school of fish moving in perfect unison. Each individual adjusts its movements based on its neighbours, creating a mesmerizing flowing pattern. This constant feedback, this intricate dance of information, ensures the school's cohesion, allowing it to navigate vast oceans as a single unified entity. Similarly, patterns in the natural world, from the formation of crystals to the intricate structure of DNA, rely on these feedback loops. They are the invisible threads that weave together the fabric of reality, ensuring the continuity and stability of the patterns we observe. Throughout the natural world, a symphony of frequencies hums unseen, a hidden language of vibration and resonance. From the smallest atom to the grandest celestial bodies, everything vibrates, everything resonates. And it is within this delicate interplay of frequencies that we find the key to optimal function, to the harmonious operation of complex systems. Consider the exquisite architecture of a spider's web, a masterpiece of engineering spun from silk. Each strand vibrates at a specific frequency, tuned to resonate with the struggles of its prey. This harmonic resonance amplifies the slightest tremor, alerting the spider to the presence of a trapped insect. This principle extends far beyond the world of spiders and their webs. The human body too relies on harmonic resonance. Our heartbeats, brain waves, even the very cells within us vibrate at specific frequencies. It is this delicate balance, this symphony of resonating systems, that allows our bodies to function with such remarkable efficiency. In the intricate web of life, individual organisms rarely exist in isolation. Instead, they form complex networks, interconnected communities where cooperation and communication are essential for survival. And just as harmonic resonance governs the function of individual organisms, so too does it orchestrate the interactions within these intricate networks. Consider the mesmerizing dance of fireflies, their tiny lights blinking in perfect synchronicity. This remarkable feat of coordination relies on a subtle language of light pulses, each firefly adjusting its own rhythm to match its neighbours. Through this harmonic interplay, the entire swarm pulsates as one, a mesmerizing testament to the power of interconnectedness. But the reach of harmonic networks extends far beyond the world of insects. The human brain, with its billions of interconnected neurons, operates as a vast harmonic network, with different regions resonating and communicating to produce thoughts, emotions, and actions. It is this intricate dance of electrical impulses, this symphony of neural activity, that gives rise to the complexity of human consciousness. From the smallest ecosystems to the vast network of galaxies that make up our universe, harmonic networks underpin the interconnectedness of all things. It is a reminder that we exist not in isolation, but as part of a larger, interconnected whole, a symphony of interconnected systems resonating in harmony. From the simplest single-celled organism to the intricate workings of the human brain, life itself seems driven by an inherent tendency towards greater complexity. This journey, as we're beginning to understand, isn't driven by chance alone. The universe, in its magnificent orchestration of energy and matter, appears to favour systems that resonate in greater and greater harmonic complexity. Imagine, if you will, a symphony starting with a single, pure note. As time progresses, more instruments join, weaving intricate melodies and harmonies. This, in essence, mirrors the grand evolutionary dance of the cosmos. Harmonic evolution suggests that this drive toward complexity, this continual layering of harmonious relationships, might be a fundamental principle governing the very fabric of reality itself. In the intricate tapestry of existence, stability is not a static state, but rather a dynamic equilibrium. Just as a symphony relies on the harmonious interplay of countless instruments, so too do systems in our universe achieve balance through a delicate dance of multiple harmonic relationships. Imagine a spiderweb glistening with morning dew. Each strand, though delicate, contributes to the overall strength and resilience of the web. Similarly, within a system, each harmonic relationship acts as a strand, interconnected and interdependent. Disrupt one strand, and the entire web trembles. It is through this intricate network of balanced harmonies that systems, from the smallest atom to the largest galaxy, maintain their integrity. Understanding this principle of harmonic balance allows us to not only appreciate the elegance of the natural world, but also to potentially influence and engineer systems with greater precision and understanding. This delicate balance, this intricate dance of interwoven harmonies, is the very essence of stability in a universe teeming with constant change and evolution. From the smallest particles to the largest cosmic structures, a grand symphony of harmonic relationships orchestrates the universe as we know it. This is the essence of universal harmony, the final and perhaps most profound principle of the Cognispheric 50. Just as a single musical note finds its meaning within a larger composition, so too does every system, every interaction, exist within the framework of these universal harmonics. These harmonics are not merely abstract mathematical concepts. They are the very fabric of reality, shaping the evolution of stars, the dance of galaxies, and even the emergence of life itself. This understanding invites us to view the universe not as a collection of isolated entities, but as a unified whole. A grand cosmic orchestra playing out an eternal symphony of existence. Within this symphony, each element, each interaction, contributes to the grand tapestry of universal harmony. To comprehend these universal harmonics is to grasp the underlying language of the cosmos. It is a journey of profound discovery, one that promises to illuminate the deepest mysteries of existence and unlock unprecedented possibilities for our future. Thank you for joining us on this journey through the Cognispheric 50 foundational principles. By understanding and applying these principles, we can unlock new potentials in technology, consciousness, and our understanding of the universe. We've explored the nature of reality, delved into the mysteries of consciousness, and glimpsed the interconnectedness of all things. From the smallest quantum interactions to the grand expanse of the cosmos, a symphony of harmonic relationships guides the intricate dance of existence. As we move forward, let us carry with us the knowledge that we are not merely passive observers in this grand cosmic drama. We are active participants, our actions and choices shaping the very fabric of reality. Until next time, stay curious and keep exploring the infinite wonders of the Cognisphere.